Okay, so the last couple days, we've been talking about two major concepts of geology. Basically, first concept was how old is the Earth? And like I've been saying all as we go along, we really can't go back in time yet. Although maybe one day, I don't know. Seriously, there are physicists who are working on theories about how black holes, if you went through a black hole, would you go back in time? Well, maybe, I don't know. Here's the problem: we can't actually get into a black hole to even try it. But they've got theories. Maybe we could. You know, so that was one thing we worked on is trying to figure out how old is the Earth, and based on the evidence that we have, we believe it's quite old, 14 billion years old. Okay. No, sorry, 14 billion is actually how old they think the universe is. 4 billion is how old they think the Earth is. So, the second thing we talked about yesterday was, well, what is Earth made of? And like these are hard questions because they're not physically things that I can like go do. Unlike chemistry, you know how like we did our chemistry lab and I made the battery. You know how I was like pretty stoked when I finally got it to work because like that's one of those kind of sciences where you can actually say, well, in theory, this is what we think should happen, and then I can go do it, right? And if what experimentally matches up with what I think happens, that's awesome, right? Physics is very similar like that too. This is a hard section here, so today then we're going to talk about theories about how Earth has then changed over time. So hence my title, Earth's Changing Landscape. And I want to pick up with where we left off last day, the idea of what the Earth is made of. So quick review. We believe that if you start in the middle of the Earth, there is a core. And then outside the core is a liquid kind of section. Here, I'll even use this thing to show again. This one's good. This literally is one of your questions on the assignment, by the way, is like draw this. So inside the silver, solid core. Around the solid core, some liquid magma. Why do we think there's liquid inside the Earth? Why do we think there is liquid inside the Earth? What evidence is there? Take a stab at it. Yeah. And so if you have an earthquake that's say over here, they find S waves over here, they find S waves over here, but they don't find S waves directly on the other side, which implies that maybe there's liquid inside. And it makes sense because volcanoes also erupt liquid magma. So there's actually a lot of volcanoes going on in Hawaii right now, by the way, if you guys read the news at all. So, okay, anyways, then there's other layers. There is the mesosphere, the asthenosphere, and the lithosphere, which is basically like building outward. And those are just the three words you need to know. The lithosphere being the outside layer, that's like the crust, which is literally the top of the earth. That's where I want to pick up our lesson today. I'm going to come back to the slide if I could. So just look at the bottom of the two slides. Here's the idea then. We believe that there are plates, literally that plates of the earth are shifting next to each other. Again, why do we think that those plates are moving? What's the evidence of that? Earthquakes, yeah. Right? Now, if the plates are moving, according to uniformitarianism, we assume that, well, if they're moving now, they probably have been moving for years, right? And we can kind of work backwards. I know you don't really do this anymore, but anybody ever see one of those like old VHS players? You know, they put in like the big square rectangular tape thing. Okay, this reference is super outdated, but normally we play it going forwards. But then you could press the rewind button, and you could actually literally on those old tapes, you could literally watch a movie in reverse, right? Well, that's kind of the theory here is that, okay, well, assuming that time is going forward, which, okay, of course it is, right? If the plates are moving this way right now, well, then if I rewind them, then I just make them go that way, and I try to figure out where things were. And it leads to this idea right here that maybe the Earth has not always looked exactly like we see it today. If we rewind it, there is evidence that perhaps it used to look like this, and this all is one spot. And one of the most commonly looked at ones is actually South America right here and Africa. Because it honestly even looks to some degree as though this little place right here fits in that spot. Can you guys see how like on this one here they actually like literally could smush together? Right? So let's talk about the evidence for why we believe this again. We know earthquakes seem to be the result of two crustal plates kind of moving next to each other. The boundary is called a fault. Okay? And as the faults move next to each other, eventually it gets kind of stuck or one goes on top and eventually has a little bit of vibrations, right? Causes the earthquake. Right? That seems to be what we recognize. And so if I go back to this slide right here, the top one, uniformitarianism is the principle that geological processes today have always operated. And so when we're working backwards, I like this guy's quote. I pulled it out of the textbook. If you want to figure out the past, he says the present is the key to the past. Because we, like I've been saying for 3 days, right? We can't go back in time. So here's the idea. If you guys want to skip ahead a slide now. About 100 years ago, a guy named Wegener had this idea. He called it Pangea, or Pangea, however you want to pronounce the ending of that, like AEA. And basically, his idea is that maybe all of the continents at one point were actually all squished together as like a supercontinent. And this is the word he used for it, Pangea. Anyone ever heard of this idea before? Them being stuck together? There's actually a lot of evidence to suggest it. And again, I'm not trying to poo-poo the idea. I'm just saying that based on what we know, that it actually makes some logical sense. Here's a picture I found. They found some fossil remains of a creature in both South America and in Africa. And right now, South America and Africa are miles apart, like separated by an ocean. And yet, if you can imagine that they were side by side, that would actually make sense that all those animals lived like right here. And they've got similar ones, like right here at the bottom of Africa and the bottom of South America, this animal fossil was found. And so they can kind of like map where they find these fossils and go, hey, they're actually like in these like zones. I like this picture here a lot. So this is currently what the Earth looks like. And they just put a legend on here for some various random things. Like, for example, right here in this red right here, I believe those are a certain type of mountain ranges. They called them folded mountains right here. And the only places in Earth that we found those particular ones are here, there, and there. And if you guys can kind of imagine that you like, put the thing back together, wouldn't it make sense that like this one right here fits with that one and that one fits with that one? And apparently maybe Australia really migrated a long ways and it was over here and it was one part of one. You get what I'm saying here? Here's other evidence. North America, there's a lot of coal deposits here and here and here and up here. And maybe if, I'll use a pen to draw now. Maybe if this stuff and this stuff had all been kind of together, you can almost imagine that like all of this stuff was all together in one band, kind of like they have right there. And so there's actually quite a bit of fossil evidence as well as like rock formation evidence where similar type stuff exists in different places. I saw one that's not in my slides here, but it was all about how up here in Norway and Sweden, you guys know the Scandinavian countries way up there? This is Norway, Sweden, and Finland. Okay. There's a lot of evidence that these guys right here might have one day been around the east coast of Canada when they actually fit together back. Well, anyways. So based on that idea that perhaps the Earth has not been in the same spot the whole time, but literally the plates, the land masses have been moving, what I want to do today is talk about the theories and the timeline of what during the main ages of the time spectrum, what people believed happened. Okay? So for the most part, if you guys want to go back, because I didn't give you time to write down some notes, let's go through those bolded words. The only one so far is just Pangea, or Pangea, however you say it. I don't know how to say the ending, honestly. So Pangea is like the idea of a supercontinent, where rewind the Earth, go backwards in time, and like squish it all together. It actually kind of makes sense. Like it even looks like it to some degree. Especially the South America, Africa bit. Like when you actually line them up, they look so similar to each other. So what I'm going to do over the last, well, I shouldn't really say last, the next couple of slides, is there are 4 main periods or eras that we kind of talk about in terms of Earth's history, going from like basically the very, very beginning all the way up till now. And we're going to try to talk about the evidence that we see and what we believe the world was like back then. And so we'll even walk through like dinosaur, Jurassic Park era type timelines too. Everybody good? Okay. So here's where we're going to start. The Precambrian era. And you probably want to write this one down. And honestly, like there's 4 of them. So maybe leave room for all 4. So first one's Precambrian, and then we'll go one at a time of the 4 sections. And I'll read off my notes and I'll describe for you, again, the evidence we have and what we believe the world was like at the time. So this would be basically as old as Earth appears to be. So we're talking like 4.5 billion to about 590 million years ago. One of the important things I need you guys to know is that at this point here, they believe that there was no life yet. Now, scientists do not have a really prevailing theory as to what made the first life come to be. But at this point here, they believe there was nothing alive. Not even bacteria, not even little single-celled worms. There was like just literally, there was the core, the mantle, and the crust, and the rocks are being formed. And the other note I have on here is that life probably couldn't exist because they think it was like over 100 degrees. Yeah. So very, very, very hot. I think the reason why is that the sun was probably burning a little bit hotter back then because the sun is eventually going to run out of fuel. Does that make sense? Like it's a long time from now, but the sun will eventually run out of fuel, and so it's probably running a little bit hotter. 4.5 billion years ago. It's since cooled down. Okay. Here's the other problem. They don't have any evidence that there was oxygen in the environment. Why is oxygen important? Yeah, like everything that lives breathes oxygen, except for plants, by the way. Because what do plants do? They breathe in carbon dioxide and emit oxygen. But yeah, so they don't think there was any oxygen in the atmosphere. Okay. So the first evidence, we've talked about this before, was the idea of cyanobacteria. And this is a picture of, I don't know whether it's actually what they found for cyanobacteria or what they believe it might have looked like. But basically, this would be like the first signs of life that we have fossil evidence of. If you guys recall from a few lessons ago, cyanobacteria, they died. And slowly but surely, they would pile up on top of each other. And as they died and piled up on top of each other, it made a fossil. And the name for that fossil is called a stromatolite. And that's the oldest type of fossil that geologists have uncovered. Stromatolite fossils from dead cyanobacteria. Does that make sense? So these things right here, when they died, the cyanobacteria, they formed the stromatolite fossils. Here's one thing that's interesting about it, though. And by the way, I don't actually know how they know this, by the way. It's well beyond what I've ever studied. But they believe that cyanobacteria made oxygen, which is really useful because other forms of life couldn't have existed until there was actually oxygen in the atmosphere. And so these bacteria, they don't need oxygen to survive. The other interesting thing I read up on them is that they believe they used chlorophyll. What other thing uses chlorophyll that we've talked about, some of us recently? What's chlorophyll usually used in? Say it? Plants, yeah. Yeah, plants are usually the ones that have chlorophyll, right? And so perhaps the idea here is that animals couldn't survive because there was no oxygen. But these bacteria, they almost function kind of like plants, where they would have breathed in carbon dioxide and breathed out oxygen, which is good because for millions and billions of years, these bacteria then were literally producing oxygen atmosphere for us. Okay. Now, later in the Precambrian era, they found very, very small creatures, jellyfish, worms, and maybe some plants. And I want to point one thing out about these things right here. None of these things have bones. So I'm going to put an X through it. They're all very, very, very primitive kind of creatures. They're all like small. They're all very fluid, if that makes sense. Bone structures hadn't really been developed yet. And I think I had a picture of some of those on a slide. Is it here? Here it is. I'll go back a slide here. But these are the fossils that they found for jellyfish, for worm-shaped animals, and for ferns, which would be like a type of plant. And so here's the imprints that are left behind in some stones. And so the theory is, well, this maybe looks like it was a jellyfish or something like a jellyfish. Okay. So everybody get what they want off this slide here? Okay. The word that I have written down bolded here then is that late in the Precambrian era, the temperatures dropped drastically. So much that we actually have a name for it. We call it the snowball Earth. The idea is that all of this really hot bacteria, because like bacteria usually grow in warm conditions, right? We even know this from nowadays. Food, for example. How do we prevent our food from going bad? We put it in a refrigerator or maybe even in a freezer, right? If we can cool it down, we can kill off the bacteria. Does that make sense? So hot conditions are excellent for bacteria. So anyways, late in the Precambrian era, it got very cold, they believe. And so the oceans froze, there were lots of glaciers, and most of the evidence they find now is like in mountain ranges. Now here's what's useful about that though. As the temperature dropped, it was too hot for like cells to normally live. But now new things were able to grow in its absence. So all of a sudden, all the bacteria has now died. But you know what the bacteria did? It served its purpose. It made us oxygen. And so what ended up happening is I should have bolded this, by the way. It has a name. It's called the Cambrian explosion. And no, Earth did not actually explode. But the idea basically is that as the temperature dropped and as there was oxygen in the environment, new life was able to form. And so there's actually a huge amount of diversity where like new animals seem to be showing up in the rock formations. Does that make sense? So that's the name for it. Cambrian explosion. And that would be like late in this period. So you know how this period goes from 4.5 billion years ago to 590 million years ago? Like we're talking 4 billion years worth of time where cyanobacteria is all we seem to have. And then temperature drops, oxygen increases, and now life can start to take over. So the Cambrian explosion is right at the end of the Precambrian era. It was about 4 billion years of cyanobacteria, which were breathing out oxygen. So now Earth now has some oxygen finally. And then couple that with a massive temperature drop, and all of a sudden now different forms of life could happen. Does that make sense? Because like we could not survive 100 degrees Celsius. You know what I mean? Like I can barely handle it when it's 35 degrees outside, let alone 100 degrees Celsius. You know what I mean? So it was way too hot for life to exist, and there was no oxygen. So those two things happen. Cyanobacteria makes oxygen, the temperature drops, and all of a sudden there was an explosion, not like a physical explosion, but like a metaphorical explosion where like a whole bunch of new life forms existed. And that's like where the jellyfish came in, the worms came in, and like more new forms of life seem to be developing. Does that make sense? So that's the name we give for it. The Precambrian or the Cambrian explosion begins then our next era. So that's basically it. That's my slides for era 1. So our next era is then known as the Paleozoic era. And so if you really had to define the first era is defined by like really nothing special happening other than just really hot, no atmosphere. Paleozoic era happens, and this is why I bolded it. I bolded it on this slide here. The Paleozoic era gets kicked off with the Cambrian explosion because now there's lots new animals and organisms. 4B? Okay. Three. Just give you one. You probably don't want to do it twice. Nope. Okay, so here's my slides on the Paleozoic era. By the way, these eras, they're not like the same time length, by the way. It's not like this one's this long and this one's this long. They're not all equal amounts. They're really divided based on major life or, yeah, like major events. Does that make sense? So this was like the pre-life era. And now we have cells, and we have cell organisms, and we have worms, and we have, I don't know, maybe frogs are starting to form, and fish and stuff like that. You get what I'm saying? And that was the Precambrian explosion. And so one of the types of fossils is known as a trilobite. And I don't know a whole lot about it, other than I believe that now we're starting to see some bone structure. But I'm not a geologist, so it's not on your test, by the way. I'm not testing you on that. But that's what I understand, is that you can start to see, this is a picture of a trilobite fossil. You can actually see some ridges inside here, right? Where the animals are getting more and more sophisticated. Does that make sense? And we've used the word index fossils before. Quick reminder, anyone want to take a stab? What was an index fossil? Same type of territory, but in different places on Earth. So if I were to find I don't know, a skeleton of something in Canada, and I were to find the exact same type of skeleton in Australia, then those would be index fossils because they must be like from the same time frame. Does that make sense? That's an index fossil. And so they find lots of these index fossils in multiple places in Earth. But here's the thing, they believe that most of these animals were in the sea. So we're probably talking mostly like fish-based type stuff. Or things that are like that, right? Like worms and jellyfish and maybe a frog. frog-like kind of creature. I don't think it's actually a frog, but like something similar to that. And how did they live? They fed on the nutrients in the soil. From what I understand, at this point here, there may not have even been very much land yet. Like land may not have really existed. So really all that there really was oceans to swim in. I don't know whether it took the plates shifting around enough, because remember how the plates shift? When they move, sometimes they move on top of each other, and as soon as one moves on top of each other, now you might have dry land, whereas like this was underwater, right? And then as this one goes on top, well now all of a sudden we have something above the water. Does that make sense? So there may not have even been land to live on, so almost everything seems to be sea-based. So anyways, those are the words we have here. We've already done index fossils. So trilobites are examples of fossils from the Paleozoic era. Okay. That's what I have written on this slide right here. Most of the life seems to be based in the sea, and there's actually a really cool example near Banff. It's called the Burgess Shale, and I believe this is actually one of my test questions. So if you want to put a little like highlight next to it, just memorize what the Burgess Shale is. Basically, it's a whole bunch of rocks found near Banff. And I'm going to show you on the next slide a little more, but I'll wait for you to copy it down first. So Burgess Shale is near Banff, and it has a ton of fossils in it. Here's what they think happened. I'm going to flip back and forth. So, oh, where is it? Here you go. This is a picture of the Burgess Shale. They believe that it looks something like this. Remember, see how everything's still underwater? Land has not managed to like push its way up above the water level just yet. And so they think there were a whole bunch of animals, whatever they were, on the seafloor. Maybe bacteria, maybe some worms, maybe some fish. I don't know. I'm not a geologist, right? And what they think happened was a mudslide. And it happened so fast that literally all the stuff that was sitting right here, this whole ridge just went whoosh and collapsed. And everything got buried underneath it. Does that make sense? And because of that, they have really, really well-preserved fossils. Okay? And they can actually look back at this time frame and say, wow, look at all the stuff that was living in the sea at this time. Side note, by the way, I read a cool article in the paper the other day there. Has anybody ever heard of Mount Vesuvius? It's a volcano that erupted like thousands of years ago. They were doing some excavating, you know, like when they're like digging for fossils and like archaeology kind of site there, and they managed to find a fossil of like an almost intact skeleton of somebody under the rubble of the Mount Vesuvius volcano eruption. So I guess what ended up happening was the lava kind of went over top, but somehow this skeleton was protected from the lava, like disintegrating it, and it was almost like in pristine condition. And they just found it a couple of days ago, which is kind of cool. I think that's kind of similar to this, is that all that life was just sitting there, and kind of like a volcano going, boom, cover you up, you're dead. But you're preserved under the ocean. You get what I'm saying there? That's what happened here, is the mudslide happened so quickly that everything's just sitting underneath there. And eventually, slowly but surely, this area turned into Banff, which is kind of cool. And so there's a ton of fossils in that area. Well, I think what I need you guys just to know about the Burgess Shale, because I asked you a test question on it, is you should know when it was that everything fell out of it. So that would be during the Paleozoic era. And just mention that the Burgess Shale has a lot of fossils in it. Okay. Due to probably a mudslide, is the theory. I want to go back with a thought here while you guys are writing out here. Remember the idea I posed about how maybe all of the continents, they had moved around a little bit and shifted around? Well, based on the math as to working backwards here, they actually believe that Alberta was near the equator. No, like Alberta right now is actually fairly north. We're kind of cold in relative terms. But if I go back even to this picture right here, you guys can see where was it? They think that most of the land mass, if this was the equator, there was a lot of it that was kind of low here. They actually believe that Alberta, right about here, was actually a tropical climate possibly. And so if Alberta was tropical, it actually leads to different conditions. Where was I here? So they believe that we were near the equator. They believe there was no life on land. It was just in the water. And they believe that the fossils were buried by a mud avalanche. This is actually a cool little anecdote. I read this one somewhere. Apparently, the mudslide happened so fast, they were able to find a fossil of like some sort of creature, and they were able to find stuff in its stomach which is really cool. They were actually able to figure out what its last meal was. I don't know what the species was, but like it got buried that quickly and that efficiently that they could look at it and go, hey, look at all those bones right there. Hey, what's that inside? Well, that must have been what it ate. Isn't that cool? So, okay, now towards the end of this era here is the Ordovician period. And this is where we're about to get into the new period. So you know how we were in, what was the first one again? The first one was Precambrian, and now we're in Paleozoic. Now I want to talk about the transition out of Paleozoic era. And so we're getting towards the end here with the Ordovician period. And up until now, we mostly had aquatic-based things. But eventually, it looks like we're starting to get some terrestrial plants. Do you guys know what terrestrial means? Terra, as like the prefix, means land. So around this time period, it looks like we're starting to get some things showing up on land for the very first time. And what's new about things on land is they need to have a backbone. And that actually seems to be a very a common changeover in these periods here, is that now there's animals that have, you guys know what a backbone is, right? Like a spine? Like one bone that runs through your entire body that things move off of, you know. Like a worm doesn't have a backbone, doesn't actually have bones at all. So, this is also the time frame that they believe that they were making those petroleum traps. Remember talking about those yesterday? The petroleum trap idea? So all that dead, decaying matter during this time period was getting buried underwater. And one of the things that you should know about this is that those marine organisms, they had been dying, and they became a food source for bacteria again. So there was actually a huge amount of bacteria at this time. Here's what they think happened. There are 4 main elements found in naturally organic stuff: oxygen and nitrogen, hydrogen and carbon. Those are the 4 main things. They believe that bacteria would eat and feed on, that's feed by the way, feed. They would feed on oxygen and nitrogen, which means that you're only left with hydrogen and carbon. You guys remember from our last unit? Hydrogen and carbon are known as the hydrocarbons. And so that's why we think that there's only hydrocarbons in our oils rather than oxygen and nitrogen, because the bacteria ate it all. Make sense? So this is actually what we mentioned yesterday. This actually isn't new information, but I just want to kind of revise the idea here. Here's what they think happened then. That organic material was heated up and pressurized, right? We talked about how rocks get pressurized. And what ends up happening is this trap. There's all this dead material at the bottom of the ocean. And then slowly but surely, a layer and a new layer and a new layer start forming on top. And I gave the analogy of being at the bottom of a dog pile or maybe at the bottom of the rugby scrum, right? The person at the bottom is getting squished, right? And eventually what ends up happening is the petroleum, the oil, kind of ends up getting squished in the middle because it can't get away from the impermeable rock. That's the rocks that it literally can't squeeze through the gaps in. Right? So it's around this time period here that the dead animals, because this is like the first time that we actually had like animal life, seems to be dying. It's getting eaten by bacteria. The bacteria takes away nitrogen and oxygen, leaving only carbon and hydrogen, and then squish layer by layer by layer. That's where all of our oil and gas seems to have come from. So that's during this time frame here. Now, this is the kind of the last period of the, what were we in? This is the Paleozoic era? Yeah, this is the end of the Paleozoic era finally here. This is the Devonian section of it. And this is where they believe all of the land masses began to collide together. This is the time where they were all stuck as Pangaea. Which I think kind of explains why now there's actually land. Because beforehand, as they all were kind of shifting around, and all these plates are moving, there was no reason for land to form, right? But as soon as they start hitting each other, what happens as they start hitting each other? Well, they start going on top of each other. It starts building up height, if that makes sense. And that height now leads to there being actual land. And so this is now finally the time frame where we actually have, I put some notes on here if you guys want to even highlight this. We now have swamps on the land. Swamps kind of make sense though, right? Because it would be really watery still. Well, an era is the longest piece of time, and then within an era is a period. I should have mentioned this. I'm sorry. Maybe I didn't do a good job of explaining this beforehand. I want a new slide here. when you draw one of those like timelines that goes like from really old to now, what ends up happening is there's four main sections, something like this, but within each section, there's like subsections. Does that make sense? So we're still currently in the Paleozoic era, and we just finished talking about what would have been the Ordovician period, and now I want to talk about the Devonian period. Does that make sense how that works? Like this is like a subsection of the main era. So the first one is the Precambrian. Yeah, so Precambrian era is the big one. And then Paleozoic era is the one we're in now, but it has all these little like subsections. The subsections are called periods. I'm sorry, I really didn't explain that probably well enough, today. So we're about to go into our third era, and then eventually the fourth one. So we're still really just in era 2. Does that make more sense now? Okay, so back to here. The Devonian period is starting to become the end of our second era. And it's marked by the idea of all of these plates were crashing into each other. And as they crash into each other, we start to get land. And because there's land, now we can get vegetation. Now there's plants. Right? And what they seem to find a lot of fossils now is reptiles. Lots of reptiles during this period. And the reason why I mentioned this earlier, reptiles are one of the first things that then have a spine or a backbone. Because all the things that used to live in the water, they could just kind of float around, or however that worked. I don't really know. Okay, the last period in this section here is called the Permian period. And this is basically leading into the start of the dinosaur era, which is going to be our next big section here. And the reason why there's the break between the Cenozoic era, which is what we're about to go into, and the Paleozoic era, which we just finished, the reason why there's a big break is because a lot of things started to die. And they have evidence of many mass extinctions. Again, keep in mind, this is before dinosaurs, so we're talking really small animals at this point. But it seemed like almost everything in the world died. Now, I have no idea how they came up with this stat. I really don't. But here's what I found in your textbook. It said they believe that over 90% and 70% of all ocean and land species died all of a sudden. And they're not really sure. They have theories, by the way. But like a lot of stuff died off. I found this graph here where there's a whole bunch of like, as these peaks happen right here, this is where like a whole bunch of animals all of a sudden started to die off. Here's some theories. One possible theory, and you maybe have heard this one before, is that asteroids and comets were hitting the Earth. Anyone ever heard that one before? Especially as the reason as to why dinosaurs maybe are extinct. That's one theory. Another one is based on like what Mr. Harrison would have taught us, is about competition. When you have all these species, invasive species, kind of coming across each other for the first time, someone is going to win out in that like fight for food and land and habitat. You know what I mean? And so a whole bunch of new animals started to form, but like not all of you can survive. Right? Another thought is that this was the time where all those plates were colliding, and so maybe there was just a lot of earthquakes and things didn't survive. And then the final thought is that as these plates are coming together, don't forget, as they're coming up, they're also making volcanoes. And volcanoes might have been spewing out a lot of magma and ash. Maybe that killed all these species. We're not really sure. But this is what ends period 2. So Precambrian era was basically all about bacteria. We just finished the Paleozoic era, which was mostly about fish-based stuff. It looks like we're starting to get some land animals by the end of it. And then for whatever reason, almost everything dies. Not everything, though, but almost everything dies. And it left a gap. It left like a big opening for a new species to kind of fill the void. And maybe you kind of know what species I'm talking about. The next era we're going to discuss involves like the Jurassic period. We're talking about the rise of basically dinosaur-type creatures, which is coming next. Oh, I got them wrong. It's Mesozoic next. So, in terms of our big 4, the first one was Precambrian, then it was Paleozoic. Now the next big era is the Mesozoic era. Cenozoic must be last. I always get them mixed up. So here's what's special about this era here. The oceans are now starting to retreat, and we have way more land. Like I said, up till now, they didn't think there was actually any territory for land-based animals to happen. And so now there's actually forests growing. And this is when dinosaurs seem to be around the world a lot. On more of a local note, this seems to be when the Rocky Mountains were formed. Because what ended up happening was as those plates are moving around, again, I've shown you this with my hands before, right? As the plates are moving around, eventually one of them goes on top of each other and it kind of comes up. We had a name for that. It was called subduction. You guys remember that word from yesterday? Subduction, where one plate goes underneath another one. And so you can almost kind of see that in this little picture right here, is that as this plate came towards this plate right here, one of the plates went downwards underneath, and the other plate went upwards, and that's where some mountains start to come from. They actually believe that there were a lot of water seas then that were actually inside the territory. We don't have necessarily that many lakes around here. It's actually one of the things that I miss. I grew up in BC, and in British Columbia, there's a lot of good lakes to go water skiing and wakeboarding on and stuff like that. In Alberta, we have some, but like, I don't know, I don't really get overly excited about Park Lake. Yeah. There's a ton of Great Lakes in BC though, right? So the reason why is that BC is more on the watery side of the mountains, whereas we're on the other side, right? This would have been the British Columbia side right here. This would be the Alberta side right here. And there might have been some water there, but eventually all this water evaporates. Whereas over here, you still had some ocean. And we still have ocean over there, right? So there's a lot more lakes on the BC side than Alberta side. Anyways, that's the beginning. This is the Mesozoic era, the third major section of time here. And I actually don't have a lot of notes on this. Your textbook's pretty brief on this, and I'm not nearly familiar with it. So the Mesozoic era is basically the main dinosaur stage era. It has, like, in terms of periods, one of them is, I think, the Triassic period. One of them is the Jurassic period. You guys will kind of recognize those as, like, Jurassic Park time terms. This actually also ended with another mass extinction, though. What died at the end of this period? Yeah. And it's actually more than just the dinosaurs. Everything the dinosaurs fed on as well. They believe that all land animals greater than 25 kilograms became extinct. So basically, if you were a large mammal, for some reason you died. And that's why I threw this picture of the asteroid hitting the Earth in, because that's one of the theories, is that maybe an asteroid hit the Earth. There's another theory, by the way. They think that maybe the plankton species may have been all eaten out. You guys remember talking about food webs back with Mr. Harrison? Oh, basically, if you take out the bottom level of a food pyramid or a food web, it kind of like screws everybody else up. Like, I don't eat probably as many vegetables as I should. You know? But I do indirectly because, an animal that I eat, like say a cow, which I love, delicious steak, right? What does a cow eat? Well, it eats vegetables, right? So if we were to take out the bottom level and like remove, all the plant life, eventually it's going to catch up with each level above it, if you get what I'm saying there. So they think that might have been a reason why too. So anyways, if I could pause for a second here, all three of our eras that we've talked about so far now were all ended very similarly. What was the similarity between the ending of all three eras? Yeah, something died. What died out at the end of the first Precambrian era? The cyanobacteria. Cyanobacteria seems to have died out at the end of the Precambrian era. At the end of the second era, which was our Paleozoic era, it seemed like most of our fish and land animals seemed to die. Now there's bigger things. Now there's mammals and there's dinosaurs, but they seem to die at the end of the Mesozoic era. So this is our final era, and this is the one we're currently in. This is known as the Cenozoic era. And I only have one slide on this because we're going to pick this up tomorrow. The Cenozoic era is marked by the temperature of the Earth starting to cool back down again. And you'll recognize the phrase, the Earth started to going into an ice age. You guys seen the Ice Age movies? My daughters watched like all 5 of them. Right? And so basically this is the time frame now where they believe the Earth started to cool down again, even more so. And we're going to talk about that tomorrow, but there's some people who actually believe we're currently in an ice age, actually. Which seems weird because you hear about global warming, but here's the reason why they believe we're in an ice age. We still have permanent bodies of ice on Earth. Where do we have permanent bodies of ice on Earth? Yeah, the poles, right? Antarctica and the Arctic, right? Whereas before this time frame, it was still too hot, and so there was no ice on Earth. So there's actually some theories that we're actually currently in an ice age, which is kind of weird because it's like, well, hang on, what about global warming? So, but that's tomorrow's topic. So, anyways, that's where I'm finishing this. Is the Cenozoic era is caused by cooling of temperatures, glaciers are beginning to form, and there's even more extinction. So the one we have here is called the Cretaceous extinction. And so more animals seem to be dying off due to temperature decreases. We seem to have stabled now with all the animals that seem to be able to live in temperatures between, I don't know, I'd say roughly about 0 to 30, 40 degrees Celsius. Because that's about how much range the Earth seems to have. Maybe in the negatives for a little bit. Not that there's a lot of animals that live at the North Pole, right? And the last note I have here, this is my last slide, right? Yeah, is that it seems like about now there were a whole lot more rodents and grasses forming, which led to hoofed mammals. Do you guys get what I mean when I say hoofed mammals? What would be an example of a hoofed mammal? A deer, a horse, an elk, a cow type thing. Does that make sense? Like we're talking four-legged mammals, right? We usually eat many of them because they're delicious. Right? And so many of them seem to have been developed based on the fact that there were a lot more grasses being formed. And that's where I'm going to leave this, because why is this era not ending with an extinction? Yeah, we're still alive, thank goodness. Right? If there was another mass extinction, geologists may decide to make a fifth time period. Although if we're dead, I don't know why we'd need one, but you know what I'm saying there? So quick summary, and then I'll give you guys hopefully 25 minutes to work today. We went through basically the history of what scientists, geologists believe Earth looked like. 4 main eras. Okay, the first era was Precambrian. There wasn't a whole lot around back then. Basically, just rock was forming. We're talking bacteria, and the bacteria would die and form into stromatolites, and that's about all we know. But here's the good news. We believe that that bacteria made us an atmosphere, which is what we needed because we need oxygen. And the temperature finally fell, because otherwise Earth was just too darn hot. Right? So that ends the Precambrian era with all the cyanobacteria kind of disappearing. Good news, though, we're starting to make some jellyfish, some worms, but no one has a backbone yet. We're not even that far yet. Mostly because there's not even land around yet. Can one of you guys grab the door for Diego? Second era was the, Paleozoic era. We're still underwater, but now there's more species starting to grow. You know, your water-based species. And even towards the end of this era, it seems like some land masses are starting to come together to some degree and merge, and we're starting to get some land-based creatures by the end of this. Okay. The one place I want you to know about was the Burgess Shale, which is by Banff, and that was where the idea is that maybe there was a big mudslide, and all this underwater stuff basically just got buried underneath, and that's where a whole bunch of fossils got made. Again, though, for whatever reason, we don't really know the reasons, at the end of the Paleozoic era, a whole bunch of stuff died. Almost all of land and water-based animals seem to. Okay. Theories? What were the theories again? Comet or asteroid hitting the Earth, maybe. Too much competition between species. Maybe volcanoes, maybe earthquakes. Those are the theories. So that's the Paleozoic era. Then we were up to the Mesozoic era. The Mesozoic era is characterized by the rise of larger mammals, dinosaurs, and anything over 25 kilograms is what eventually died out at the end of this era. And again, we're not really sure what the reasoning was. Maybe a big asteroid hit the Earth. Okay. One more thing, though. At the end of this era, what else happened to the Earth that was really important? It cooled down even more, to the point where we're actually now to the point of the Ice Age. And like I said, people believe we might still be in an Ice Age because there's actually ice on Earth. There didn't used to be ice on Earth, but there is right now. And Earth cooled down drastically. That's this era right here, the Cenozoic era. Plates are moving northwards. We're colliding. Because things are moving more north, we're getting colder. And this was the Cretaceous extinction, which was basically the one that kind of ushers in this new era. Why are we still in this era? Well, because we're still alive, right? And so that's currently the present. So tomorrow's our last set of notes then. And no, not tomorrow. What are we going to do? Monday. Monday's our last set of notes. And what we're going to do on Monday is we're going to talk a little bit about climate change and that concept. And we're going to start by discussing, though, how the temperature of the Earth seems to have changed a lot over history, from really warm when it started to getting colder now. And we'll talk about the implications of what that means going forward for us, because um, I don't think it's probably unfair to say that there are people who believe that human history is going to end very soon. Like there are doomsday people who believe we're going to see in the Bill Nye video I give you. There's a guy who like has literally like built himself his like own bomb shelter, and he like hides out in a cave away from the rest of the world because he really believes that like the Earth is going to end in 10 years, and it's because we're going to like heat it up so much that we can't survive anymore. So now I don't know for sure that's going to happen or not, but that's a possibility as to how this era could possibly end. Is that it'll start heating up too much and then we'll all die because it got too hot. So, anyways, that makes sense. Cool. Okay. I can give you guys a decent chunk of time now to work. You should be able to do almost all the questions on the assignment. Okay. So, and that's really one of the few things we're going to do. One's the assignment. Two is those notes you've been taking. Next week, we'll do our other two activities. We'll watch Bill Nye's video next week, and we'll spend one day doing some research on climate change. And that's really it for our unit.